dramatically increasing, as you know that already. So just we'll start. So first, let us discuss about what are the advantages of electric vehicle. So the first advantage is it reduces the local air pollution. Actually, of course, if we get 100% from the renewable energy, then only it will reduce the total air pollution. But if you get from fossil fuels, then 100% not reduction, but of course it can reduce the localized air pollution. That's the first advantage. Next, better for the electrical network. That means during night time, especially lighting load is less. After 10 o'clock, the lighting load is less. At the same time, the renewable energy like wind energy continuously producing power. So the power can be effectively utilized by charging the electric vehicles. Otherwise, some of the powers will be wasted, and the windmills will be normally shut off. Suppose the peak load is less, means normally power plant will produce less power. At the same time, some of the windmills will be stopped. So if you charge that electric vehicle during night time, we can effectively utilize the electrical energy. Next, better for our energy security because it will reduce the import of oil. Therefore, energy security it can cover. Next, when compared to gasoline or diesel vehicles, the running cost per kilometer is less, about 1 rupees per kilometer. When compared to gasoline, it is about 5 rupees per kilometer. Next, another biggest advantage is quiet operation because some of the motors can work very silently. Therefore, the noise will be less when compared to ICE engine, and we no need to use muffler or silencer. So that is one of the biggest advantage. Next, another advantage is maintenance cost is less because of less moving components. Next, the government also providing some subsidy, so that will be benefited. So anyhow, the cost of the electric vehicles are higher than the conventional vehicle, but in future the cost will be reduced. These are the advantages of electric vehicle. So while discussing about the advantages, we have to think about downsides of the electric vehicles too. So the first major drawback is it is suitable only for short ranges of driving, maximum 200 to 300 kilometers only possible. Of course, in future it can be increased to beyond 500 kilometer, but nowadays it is maximum 200 kilometers. Next, charging can take a lot of time. This is one of the major drawback of electric vehicle, because the faster charging is always reduces the battery life. So ultimately, overall cost also will increase. Therefore, charging is one of the problem. That problem yet to be solved. Next, initial cost is extremely high when compared to conventional vehicles. The cost will be 3 to 4 times higher than the conventional vehicles. So that is one of the biggest issue. Next, charging stations are not available everywhere. Of course, some of the chargers we can do it in our home itself, but sometimes convenience point of view it is not good. Next, another biggest problem is fire hazards due to battery issues as well as electrical issue. It's one of the most dangerous problem existing in that electric vehicle industry. So another biggest problem is availability of lithium. So the lithium is available only few countries like mostly South American countries like Chile, Argentina, and Bolivia, and also Australia also. Of course, the cost of lithium is dramatically increasing day by day because of the demand. So overall cost of the electric vehicles also increase. So another problem is making electric cars creates more emissions. Emissions mean indirect emissions. So during mining operations, we are using conventional diesel vehicles. So that emits more emissions. Mining, the emissions due to mining is very high when compared to other gasoline vehicles. Of course, the problem is only the initially. After that, the problem will be solved. That emission problem is not a big issue, but initially the emission rate is too high, and the during production also we are spending more energy, so that also you have to consider. So these are the downsides. So next, this is the common ICE engine vehicle. So already you know, it is one engine, and torque converter means gearbox, then transmission. Transmissions is a differential to wheel. This is the common ICE engine vehicle. So in the case of electric vehicle, we are replacing engine into motor, which is powered by battery. So this is the common ICE engine vehicle. So next, electric vehicle. So in the case of electric vehicle, we are replacing engine into electric motor, and which is powered by the battery pack. Understand? Some of the major components of electric vehicles are, the first one is the battery pack, which supplies energy. Normally it's made of lithium ion battery. So next one is the motor, which drives the vehicle. Next one is the power electronics controller. That only controls all the motors, battery, everything it controls. Next one is a DC to DC converter. DC to DC converter because it requires because some of the components inside the vehicles requires lesser voltage. So we can reduce the voltage for other purpose. For example, dashboard instruments, to operate dashboard and other instruments, we need less power, less voltage. For that purpose, we use DC to DC converter. And finally, it is cooling system. These are the major components of electric vehicles. So first one is power electronics controller. Next one is battery pack. Next, electric traction motor, charging port, DC to DC converter, onboard charger, thermal system for cooling. Finally, it's a transmission. These are the key components. But in this session, we are mainly going to focus on battery system. Next one is first component, the power electronics controller. So it controls electrical energy delivered by the battery. That means during acceleration, it gives more current, and during deceleration, it reduces it. Overall, it controls the amount of energy delivered by the battery. And the speed control and reverse, taking reverse, everything is controlled by the power electronics controller. And one of the biggest advantage of electric vehicle is we can use regenerative braking. Regenerative braking means while applying brake, we are converting kinetic energy into electrical energy. That electrical energy will be stored in the battery. That can be effectively used. Therefore, overall efficiency of that vehicle will be improved. So this is the biggest advantage. So in general, power electronics means it is the overall control of the vehicle. It acts like a brain of the system. So this is the battery pack. So normally it is placed below the passenger seat. So these are the battery pack. The packed like this. So while choosing the battery, we have to consider so many factors. First one is it should have long life and safety, better safety, and the cost wise it should be cheap, and it should have very high capacity. So normally for cell phone we use mAh, but here we use ampere hour. Because of very high capacity, we use ampere hour, high capacity. And you should have high specific energy. I mean kilojoule per kg or something watts hour per kg. Next, it should have high specific power. High specific power means the rate of releasing the electrons. So it is important for hill climbing as well as sudden acceleration purpose. The high specific power is important. Next, better performance at different weather conditions. Most of the batteries do not work at low temperature. The battery should work at different temperature. Then only it is suitable for different weather climates. So these are the guidelines for electric vehicle battery selection. So next, so normally the four kinds of batteries commonly used. Of course, sodium and potassium ion batteries are under development. Maximum we use lithium ion batteries. In earlier, just 10 years back, we have used nickel metal hydride batteries. But nowadays we use almost 100% lithium ion batteries only we use. And the sodium ion batteries, potassium ion batteries, all are under development. So first, let us talk about nickel metal hydride batteries. So definitely it is cheaper than the lithium ion batteries because lithium is one of the expensive metal when compared to nickel. And when compared to lithium ion battery, it is safe. Next, the drawback is it has very low energy density, 80 watts hour per kg when compared to lithium ion battery. Lithium ion batteries normally have more than 50 watts hour per kg. And another biggest drawback of lithium metal hydride is it can charge only 500 cycles. I mean, we can use maximum 500 cycles. 500 times we can charge or discharge. Another biggest drawback of this one is high self-discharge. That means if you keep that vehicle 2 or 3 days under idle conditions, so because of self-discharge, the vehicle cannot start or so it cannot work. So these are the drawbacks of nickel metal hydride batteries. Okay. So lithium ion batteries are very important. because almost 95%, more than 90%, 95% of vehicles use only lithium ion batteries because the lithium has very low molecular weight. That means atomic weight or molecular weight, it is relatively even lesser than the sodium or potassium or aluminum, whatever maybe. It is the lightest metal ever found in the earth. So therefore, the demand for lithium-ion battery is extremely high when compared to other batteries. So the some of the lithium-ion batteries are lithium cobalt oxide batteries, lithium manganese oxide batteries, lithium nickel manganese cobalt oxide batteries, lithium iron phosphate batteries, lithium nickel cobalt aluminum oxide batteries, lithium titanate batteries, solid state ion batteries, lithium sulfur batteries, lithium air batteries. Like that, so many kinds of lithium ion batteries are available. So each and every batteries have own merits as well as demerits. So we have to choose the right lithium ion battery, then only it will be safe. Some of the batteries are not safe. Easily it may catch the fire or sometimes it may explode. So we have to avoid that kind of lithium ion batteries for electric vehicles. So, okay, let's talk about the components of lithium ion battery. So it has 4 major components. A battery has anode and a cathode. These two are the electrodes. Next, a separator that separates 2 electrodes. That means the cathode and anode should not contact each other. If it makes contact, automatically it may cause the fire accident. So for safety reasons, always you have to keep a separator between 2 electrodes. Next, one electrolyte. Normally, it is a lithium salt. Through that electrolyte only, the lithium ions are moving towards either anode or cathode, depends on the charging discharging cycles. So finally, 2 current collectors. From that current collectors only, we can get the power output. So totally 4 components: electrodes, separator, electrolyte, then 2 current collectors. So it is explained in this diagram. This is the cathode. Cathode may be a kind of lithium alloy metal. Rarely we use lithium metals because if you use lithium metal, it may catch the fire easily. It is too dangerous. So for that purpose, we use some other different kind of materials along with the lithium ions that will act as the cathode. And this cathode as well as anode both are separated by a separator. Separator do not allow cathode to touch the anode, but it has a lot of pores. Through that pores, the lithium ions can move either from cathode to anode or anode to cathode. And during discharge, the electrons will be released. This is the load. Load means we are supplying this electrons to the electric motor. Next, we should know that how a lithium-ion battery works. During discharging, the electrons flows from from cathode to anode or anode to cathode, depends on that charging, discharging condition. During discharging condition, normally electrons will be released. That means the electrons will be used to drive the electric motor during discharging. So this is the lithium ion battery. During discharging, it releases electrons. This electron only drives the electric motor. And the lithium ions move from cathode to anode. So the lithium ions forms because of release of electrons. If there is no release of electrons, there is no lithium ions. So for us, required one is this electron. This electron only helps to drive the vehicle. This is happening during the discharging operation. During charging operation, we are supplying electrons from external source. Through the electricity, we are supplying this electrons. So again, what will happen? This will become, of course, lithium ion phosphate is one kind of battery, cathode. So the concept is very simple. During discharging, I mean working, the electrons will be released. The electrons will be utilized by the electric motor. At the same time, during charging, the lost electrons will be supplied from external sources. Like this, it is working. So this charging process also same. During the charging process, electrons will be supplied from the external source. So, okay, now next to discuss about advantages and disadvantages of each kind of batteries. The first battery is lithium cobalt oxide battery or LCO batteries. This kind of battery is commonly used in laptops or any cell phones or common electronics devices. It is mainly used, and of course it has a nominal voltage. The voltage point of view, this is very good. It gives 3.6 volt per cell. Normally above 3 is better. So voltage point of view, it's good. Next is specific energy point of view also, it is okay, approximately 200 watts per hour kg is okay, it's good. And the maximum we can achieve 240 watts hour per kg. Next, one of the biggest problem of this one is if you discharge, charge during charging or discharging, if you supply, for example, charging, if you supply very high amps, so it may catch the fire. It is very dangerous. So high rate chargers should not be used for charging this kind of lithium cobalt oxide batteries. So maximum 1 coulomb charge rate is 0.7 to 1 C is correct. So if rapid charging means it is too dangerous. Next, discharge. Discharge also 1 C. 1 C means it is not possible to run very large size motors. That means during acceleration, enormous amount of electron is needed within a short period of time. So if you consume much quantity of electron with a short period of time, it is too dangerous. So for that reason only, sometimes the cell phone exploding or laptops are exploding because of rapid charging or rapid discharging. These two are highly undesirable in the case of lithium cobalt oxide battery. So because of the reason, Of course, the specific energy is higher than the other kinds of batteries. This kind of batteries rarely used in electric vehicles and it's not suitable. So another drawback is the life cycle is less. I mean, so we can charge maximum 500 times to 1000 times. Roughly 2 years, 2 to 3 years, we can manage. Beyond that, it may not work. Even if it works, it may cause fire accident. Cycle life is less. Next, another biggest problem is thermal runaway. Thermal runaway means if the battery temperature exceeds beyond certain limit, the entire energy of that battery will be released suddenly. That may cause severe explosion. Not only fire accident, it may cause explosion. So while choosing the battery, we have to think about thermal runaway. So the maximum, for example, lithium cobalt oxide can withstand up to 150 degrees centigrade. Suppose if any failure in the cooling system happens, immediately it will explode. So it is highly dangerous to use in the electric vehicle. Of course, we use in the cell phones as well as laptops. So some of the advantages are very high specific energy, but another one of the major drawback is cobalt. Cobalt is one of the expensive metal, like more expensive than the lithium. So because of that reason, its application is limited to only some of the common electronics devices and rarely we use for electric vehicles. Next, another that is lithium manganese oxide. So voltage is high. Voltage high means we can charge rapidly. But excess volt more than 4 is not desirable because it may damage the electrolytes. So that factor also we have to consider. Next, the specific energy is relatively less when compared to lithium cobalt oxide battery. The specific energy is very less. It is about 100 to 150 watts hour per kg. But it has some advantage. 3C, charging rate 3C, that means we can charge rapidly. 3 times rapidly than when compared to lithium when compared to lithium cobalt oxide, we can charge it rapidly. At the same time, we can discharge that discharge rate also very high. That means sudden acceleration or hill climbing is possible. If you use lithium manganese oxide, it rapidly releases the electrons. Therefore, we can manage hill climbing or sudden acceleration. And another drawback of this one is cycle life is less. It's one of the major drawback. That means the battery we cannot use more than 2 years. And when compared to cobalt battery, this can withstand up to 250 degrees centigrade. So a safety point of view, when compared to that one, it is better. So major drawback of this lithium manganese oxide battery is less capacity. So lithium manganese oxide means it is the cathode. Anode is always graphite. So in the battery point of view, we mainly focusing on cathode. Anode is almost graphite, almost for all the batteries, we use graphite. And the electrolyte is commonly used as lithium fluoride. And the separator is some kind of polyolefins. So these are the common material. But the cathode only we are changing, depends on the battery. Next, NMC battery. This is one of the most common battery used in electric vehicle. So here we use lithium, nickel, manganese, cobalt oxide, like that, three combinations. So these combinations are mainly used to increase the specific energy. So in general, lithium manganese oxide battery is better. But if you add these materials slightly, we can save the cost, as well as overall cost will be reduced. At the same time, the capacity is increased from 150 to 220. We can increase up to 220 watts hour per kg. This is the biggest advantage of this one. And but here we use cobalt oxide, therefore the charging cannot be done very fastly. 1C only possible, 0.7 to 1C, because we use cobalt oxide. But discharge rate is almost increased when compared to cobalt oxide. 2C is possible. Already I told you, high discharge rate is important for the grade climbing or hill climbing, as well as sudden acceleration. And the cycle life also increased, but still it has one problem: thermal runaway. If the temperature exceeds 210 degrees centigrade, it could explode. And the cost wise, about $420 per kilowatt hour. This also good. So it is commonly used in some of the e-bikes, as well as electric vehicles also commonly using, especially Tesla using this kind of NMC battery. So this is one of the best battery, but still safety point of view, it is not good. The temperature, it can withstand up to 210 degrees centigrade. It is not the safe battery. Next battery is lithium iron phosphate battery. This is one of the safest battery, and it has very high cycle life. Because of that reason, most of the electric vehicle used in India as well as China, they use lithium iron phosphate, LEP battery. Especially NMC batteries are common in United States, and the lithium iron phosphate batteries are common in China as well as India. Of course, we are importing batteries normally from China. Therefore, lithium iron phosphate battery also, almost in India, we use only lithium iron phosphate battery because of the safety reasons. This battery is invented by Nanjunda Swami, Indian only. They are working in the United States. They only invented this battery. When compared to all other batteries, this battery is better. But still it has poor specific energies. The rating is about 90 to 120 watts hour per kg. It is lowest among other batteries, 90 to 120, but it can be increased by carbon coating. The specific energy can be increased by some kind of carbon coating. So this problem, most of the scientists are working towards increasing the specific capacity, specific energy of lithium iron phosphate battery, because this is one of the safest battery. Thermal runaway range is about 270 degrees centigrade. It is stable up to 270 degrees centigrade, and the chemical as well as physical structure is so strong when compared to other batteries. But cost-wise, it is not cheap. But because of the research and development, the cost also drastically now reduced. Of course, just $580 per kilowatt hour just 2 years back. Now it may come down about 400 kilowatt per hour. And one of the biggest advantage of this one is cycle life, 2000 and higher. That means nearly 8 years we can use. 8 years we can use a single battery. This is one of the biggest advantage. And here also one drawback is the self-discharge. That means if you are not using the vehicle for a few days, so it's very difficult to start the vehicle. That is one of the problem. So most of the scientists are working in this battery only, lithium iron phosphate battery, to improve the electronic and ionic conductivity. And here the discharge rate is possible up to 25C. Possible at 25C, but practically it's very difficult. It has poor ionic conductivity. Because of poor ionic conductivity, the discharge as well as charging is very difficult. So this factor also we have to consider. So we have to focus on charging to improve the charging rate as well as discharging rate of the battery. Lithium iron phosphate battery is one of the best battery among the lithium ion batteries, but some of the drawback is it has poor specific energy. We have to increase it. So research is focusing on this kind of one. So next, another best battery is lithium nickel cobalt aluminum oxide battery, or a NCA battery. Almost most of that, including Tesla also, they are using this kind of battery because the specific energy is very high and the cost of battery is relatively cheap. But still, this battery has some drawbacks. Charging rate is very less, 0.7C. 0.7C means extremely poor charging rate. And discharge rate also very less, 1C only possible. 1C is possible means sudden acceleration or hill climbing is very difficult. And another biggest drawback is cycle life. It has very limited cycle life, nearly 1.5 years only we can use. After that, you have to replace complete set. Even though the initial cost is less, so cycle life also it is too less. So this is one of the drawback. And another biggest drawback is thermal runaway. The thermal runaway problem is mainly because of cobalt. If cobalt is present means it is too dangerous. So normally cobalt is added, it's at very low level, but even at a very low level, it reduces that thermal runaway temperature drastically. So this is one of the biggest drawback of lithium nickel cobalt aluminum oxide battery. But still, most of the electric vehicles, they are using this battery, even though thermal runaway problem is major issue. But thermal runaway problem can be sorted out with the help of effective cooling arrangement. But cooling arrangement fails means definitely it will explode. That is one of the biggest issue. Next battery is lithium titanate. Lithium titanate means titanium will be used as the anode instead of graphite. Normally graphite will be used, but here we use titanate. The cathode may be any kind of material. It may be lithium iron phosphate or lithium manganese oxide, whatever may be. But the biggest advantage of this battery is excellent cycle life. The cycle life is about 3,000 to 7,000. Very high self-life is, cycle life is mainly because of its low voltage. Low voltage means the electrolyte will not be condemned easily. It will take longer time. And still the charging time also can be increased above 5 times, and discharge rate also up to 30 coulomb, 30 C is possible. So that means a rapid charging as well as discharging is possible in the case of lithium titanate. But the major drawback is specific energy is less. Specific energy capacity is less means we need more number of batteries or more weight. The weight of that vehicle will be increased. So this is one of the drawback. But one of the major problem of this one is higher cost. 1,005, almost double the times the lithium iron phosphate. So this is one of the drawback. So this also under research only. Scientists are trying to improve the capacity. So next, lithium sulfur battery. This battery is future battery. Of course, some of the prototypes are already established, but still it has a lot of drawbacks. It has so many advantages. That means the cost wise it is cheap, and the specific energy is about 550 watts per kg, which is almost 3 to 4 times when compared to other kind of batteries. So lithium sulfur battery biggest advantage is this about 550 watts per kg. 550 means 3 times nearly, 3 to 4 times when compared to lithium iron phosphate or lithium manganese oxide, whatever may be. But and at the same time, life cycle also it's very high, about 1,500 cycles. Cost wise it is cheap, but it has very it has some unwanted problems too. Still it is under development stage, it is not yet commercialized. And another problem is leakage of active material from the cathode. That means after sometimes the life is less, and the volume expansion of the sulfur cathode, this is one of the biggest issue. Volume expansion means during charging the volume of the battery is increasing, during discharging the volume of the battery is decreasing. So continuous expansion and contraction may leads to mechanical failure. So volume expansion is one of the major drawback of lithium sulfur battery. Even we can look into some of the old batteries in your cell phone. Volume expansion during charging discharging is common. Even we can look into the cell phone battery too. So another issue, because of very high capacity, automatically spark problem, some kind of safety issue also major issue. So anyhow, lot of research work is going on this lithium sulfur battery because of its high capacity. That means the overall weight of the electric vehicle can be reduced. This is the biggest advantage of lithium sulfur battery. It is a future battery. Nowadays we are not at all using. It's a future battery. Next one is lithium air battery. So it has very high capacity. So when compared to normal lithium ion battery, it is nearly 6 to 10 times higher capacity than the normal lithium ion battery. And it is almost very light because of use of air. We do not use other metals than the lithium. We use only one non-metal is lithium. So air is a lightweight. This battery uses oxygen from the air as the cathode. So because of its lightweight, it has very high capacity. But still it is under development stage. And this battery also developed by Indians only. Some of the drawbacks of this lithium ion batteries, it has poor stability. Poor stability means life is less, and any abuse, that means over discharge or overcharging, may leads to explosion. That is one of the biggest problem of this one lithium ion battery. And self discharge, another issue. Volume change, poor cycle life. Life is less. That means periodically we have to replace the battery. And drastic reduction in power at cold temperature. That means it is not suitable for low temperature conditions. And it consumes 30% of its stored energy for pumping, because air should be pumped. So pumping cost also, it takes about 30%. Therefore, the efficiency of the battery is less. Even though it can offer very high capacity, the efficiency of this battery is less, and a lot of research workers going on this battery too. So next battery is potassium ion battery or KIP battery. This also a future battery. Of course, some prototypes models are available. And most of the scientists in India as well as abroad, they are working on this potassium ion battery, because the charging rate of this battery is extremely high. Quickly we can charge that battery. But unfortunately, because of higher weight, nearly 8 times the weight of this potassium is 8 times higher than the lithium. Because of the higher weight, the capacity of that potassium ion battery is relatively less. So main advantage is potassium is abundantly available. And it has other drawbacks like a low capacity, large volume expansion, and poor life. And sometimes side reaction also possible. It will release the water that will further deteriorate its life. So these are the drawbacks of potassium ion batteries. So this also under development because potassium is abundantly available. So next one is sodium ion battery. When compared to potassium, it is safe. And the sodium metal is abundantly available. Of course, sodium chloride is one of the main components of the seawater. So availability is not at all issue, but still it is expensive, and it is not developed and not commercialized yet. Still it is in development stage only. Still, it has some drawbacks like high self-discharge, low capacity, and hydrogen. Sometimes it may release hydrogen. It is too dangerous, it may explode. And volume expansion also another issue in that sodium ion battery. So, okay, of course, a battery is the main component of electric vehicle, and other components are already established. And our research is mainly should be focused on batteries. Of course, battery is an electrochemical device. The problem is not in the electrochemical related work. The major problem is thermal management. That means the temperature should not exceed beyond certain limit. That may leads to thermal runaway and explosion. So solving thermal runaway problem is one of the major thrust area of research. And one method is conventional cooling by using some kind of nanofluids or a radiator similar to radiator, we are cooling. In the improvement in the area of cooling is preferable, active research area. But another method is developing safe cathode material. That is good when compared to improving improving the cooling system. Development of effective cathode is better, and cathode preparation is mainly a material science, material technology, as well as materials technology combined with nanotechnology. So this is one of the active research area. So mechanical engineers can do in the research in this cathode preparation, because it is materials. And you no need to bother about the electrochemical reactions, because electrochemical reactions are already established. The problem is preparation of nanoparticles, cathode nanoparticles. That is one of the research, active research area. Next, another one is improving electronic and ionic conductivities of cathode material. So this also related to material science. Electronic conductivity is important for the sudden acceleration or hill climbing. It is very important. And ionic conductivities are important for quick charging. So most of the batteries are lacking in both the electronic as well as ionic conductivities. Electronic conductivity can be improved with the help of some kind of carbon coating. There are thousands of carbons are available. So some carbons are effectively improving the electronic conductivity. So this is one of the active research area. And ionic conductivity improvement with the help of some kind of porous structure, that also good. So these are the major research areas in batteries. So okay, batteries over. Next, let us talk about electric motors for electric vehicles. So commonly, 4 kind of motors are used. First one is brushless DC motor, permanent magnetic synchronous motor, and 3-phase AC induction motor. Next is switched reluctance motor. These 4 motors are very common. Among these 4, 3-phase AC induction motor is cheap and I mean inexpensive. But when compared to other motors, control is somewhat difficult. And brushless DC motors are commonly used in two-wheeler or 3-wheelers. And that means we can adjust, it does not require external gear system. That means the torque can be adjusted very easy in the case of brushless DC motor. And the permanent magnetic synchronous motor also used in is common. So for high speed applications, SRM motor is common, a switched reluctance motor. So these are the common motors used in the electric vehicles. Indian electric cars normally use the standard IEC 60309 industrial blue. I mean, so the charging ports also some standardized. For India, it is one standard. For European Union, another standard. In United States, they are following another standards. But in India, we use IEC 60309 industrial blue. This is common charging port. Next one is DC to DC converter. So of course, the DC voltage offered by batteries are too high. And the instruments inside the panel dashboard requires less voltage. So in that case, we have to reduce the DC voltage into required voltage. For that purpose only, we use DC to DC converter. Sometimes it increases the voltage or sometimes it decreases the voltage. It depends on the requirements of the motor or requirement of other accessories like the AC and dashboard panel instruments. So that also you have to think DC to DC converter. Next, onboard charger. Charger also very important. And rapid charge is charging also possible. And normal charging, as well as AC charging, DC charging, like that. So many types of chargers are available. AC charging is about normal AC charging is for about 2.5 kilowatt to 3 kilowatt range. It is suitable only for two-wheeler as well as four-wheeler, smaller range. For electric vehicle, heavy vehicles, I mean light vehicles like cars, we use fast AC charging. And more than 30 kilowatt, we have to use DC charger. So these kind of chargers are commonly used. But whatever may be, fast charging always will reduce the life of the battery. Next, cooling system. So the cooling system is very important for the electric vehicle because the higher temperature always leads to thermal runaway or explosion problem. So effective control of cooling system is very important. So this works similar to the conventional radiator. This is the conventional radiator and it's a coolant. Coolant is circulated by the pumps and it is circulated among the onboard charger. Next, DC to DC converter, inverter, traction motor, everything is cooled by the this cooling system. Battery, I mean inverter means here is the battery. So that the passenger can be travel safely. Otherwise, it is very important, very dangerous, because cooling system failure means definitely the battery will explode, because continuously the temperature is rising and batteries are packed inside a closed container and it is fully insulated. Fully insulated means any failure happening in the cooling system may leads to increase the battery temperature dramatically. So effective cooling is very important. So thermal management, this is also one of the active research area in the electric vehicle. So, okay, some of the common electric vehicles. First one is battery electric vehicles. That means it is fully driven by the battery. Another one is plug-in hybrid electric vehicle. Next, a hybrid electric vehicle, fuel cell electric vehicles. These are the common types of electric vehicles. So battery vehicles, electric vehicle already, you know, it is fully driven by the battery. plug-in hybrid electric vehicle. So here hybrid means it is the combination of engine plus battery. So vehicle normally runs with the help of battery until it is deflated. After that, automatically it will be switched over to IC engine. It's a hybrid vehicle. So the biggest advantage of this kind of vehicle is we can use regenerative braking system. Regenerative braking system means while applying brake, the kinetic energy of the vehicle will be converted into useful electrical energy. The electrical energy will be utilized by the electric motor. So therefore, overall fuel efficiency will be increased dramatically. That is one of the advantage of using this plug-in hybrid electric vehicle. So next one is hybrid electric vehicle. Hybrid electric vehicle means here the battery is not charged by the external plug. It is charged by only the IC engine. And the biggest advantage of this kind of hybrid vehicle, hybrid electric vehicle is it can increase the fuel efficiency dramatically, but cost wise it is not cheap. So next one is fuel cell electric vehicles. Fuel cell electric vehicles means normally fuel cell means it is the direct conversion of fuels into electricity. Especially we use hydrogen. The hydrogen finally will be converted into electric energy directly with the help of the fuel cell. That will be used to drive the electric motor. So this is called a hydrogen fuel cell electric vehicle. But I think only one fuel cell vehicle is introduced in India, in Kerala, I think. So almost the volume of penetration is still less. But in future, the demand will increase dramatically because fuel cell do not produce any pollution. And here there is no combustion reaction, no release of CO2. So this is one of the best future vehicles. So, okay, thank you. So participants, you can ask any queries.
Participants, if you have any queries, you can please.
Sir, while comparing all the batteries, which is the best battery for at present which is invented?
So actually, currently for India point of view,